Cool. Right, okay. So anyone that read the abstract for this event, because we all read those things, don't we, will see that I said I was going to do a back-to-front talk. So what does that mean? Well, it means that I'm going to do the whole thing sort of arse about front. So I'm going to start off with sort of the conclusions. I'll move through the content sort of backwards, and then I'll introduce myself at the end. Okay? So do we have any questions on today's talk? Yeah, I know, obvious. So how many people know this book? Hands up if you know this book. Okay, you should know this book. It's a very good book. The editors and a lot of the contributors in the room. But the title to this book is basically how we achieve quality in a continuous delivery environment, which is that we build quality in. How many of you know this book? None of you, because I haven't created it, because that would actually involve doing lots of work. I spent 5 minutes on Photoshop, but the title to this is the answer to the important question of how do we achieve security in a continuous delivery environment. So the format of this talk is that there's 5 sort of 3-point sections. So it means that you can kind of tick it off as you go along and you realize how much more you've got to endure. So we're going to start with the final reason. I'm not going to get bored of this backwards thing, by the way. The final reason that continuous delivery is more secure than the alternatives is team size and cross-functional teams. So essentially, with a cross-functional team, it means that the team is responsible for the end-to-end process of the software, all the way from the business concept through the implementation, through all the testing, into production deployment and configuration. And the reason that this makes things more secure is that the places that vulnerabilities hide in software is in all these little sort of gaps. And what I'm about to give you here is called a tenuous metaphor. Yep, like coins down the back of an old sofa. Okay, so essentially, whenever you've got handoffs or boundaries between sections of teams is where quality issues hide, and security is just a subset of quality. So continuous delivery is more secure because we have cross-functional teams that own features from end to end. The second reason that continuous delivery is more secure is batch size. So when we make a release in continuous delivery, we tend to use small batches. So obviously, it means that we have isolation of cause and effect. So with a small batch like you got on the left, essentially there is one feature, and when something goes wrong, or if something goes wrong, I should say, then essentially you've only got one problem to deal with. And if you need to roll back, you're only going to actually lose one feature, as it were. If you've got 3 features, then obviously it's much harder to isolate. But actually, it's much worse than that, because we don't tend to release software just as a chunk. When we release a feature or a batch, we're releasing it and we're integrating it into an existing system. So in the same way as we said with the sofa analogy, we're talking about the gaps between things. A lot of the quality problems that we see, particularly security problems, tend to be the way that features integrate with other features. So for example, a new feature doesn't properly integrate with existing authentication. It doesn't properly integrate with the session. It doesn't properly integrate with authorization and access controls. So essentially, when we talk about releasing a single feature, then the way that it interacts with the existing system is quite predictable. When we release 3 features, then essentially it's not just the way that it interacts with the sort of existing system, it's also the way that all of those things interact with each other. So the more features that you add, this complexity doesn't just grow linearly, it grows exponentially. So small batch sizes are much better for security. But there is a warning with small batches. With any sort of iterative process, we need to make sure that we do allow emergent design to happen. Because one of the problems, one of the anti-patterns that you often see with iterative development is that instead of ending up with emergent design, you end up with no design. And if you end up with no design, then you get this sort of thing happening with your system. Rather than actually having each release continuously reassessing the whole, you end up just sort of bolting a new bit on a new bit at a time. And to really stretch the analogy, imagine trying to secure this building. It's not going to be the easiest thing. So the first reason that continuous delivery is more secure. At this point, I need to introduce our players. So obviously, we've got the white hat, which includes all the U software developers up on the top left, and we've got the black hat down here. Everybody's heard the term white hat, black hat? Does everybody know where the terms actually come from originally? Slide to side. Okay, so black and white silent films in terms of cowboy films. Obviously, really grainy video. Things really great, not video, film. Things moving really quickly. The bad cowboys always used to have black hats, and the good cowboys always had white hats, so you could easily see which group of cowboys you were looking at a time. So that's where it comes from. So us, the white hats, are releasing some software. So we do a release, we find a vulnerability, and we fix a vulnerability. I'm going to have to apologize just right now actually to Steve, because this might look quite familiar if anybody's seen Steve's release testing talks, but imitation is the sincerest form of flattery. So when we release software, assume there's a vulnerability in it. And the reason we have to assume there's a vulnerability in it is it's impossible, if you use any dependencies at all, to release software and guarantee it to be vulnerability free. Because essentially, even if it is vulnerability free at the point that you release it, a vulnerability can be discovered in a dependency that you use at any point later in time. So even if you're doing the right thing and you're running OWASP dependency checker as part of your continuous integration build, at some point later, that vulnerability could be found, even if you are perfect. And software teams aren't perfect, so there might be other vulnerabilities in there. Essentially, this timeline, there is also an attacker timeline, which is the attack window. So essentially, in continuous delivery and in security, all we're trying to do is reduce the attack window for the black hats. Now, our release, find vulnerability, fix vulnerability is split into two parts. There's the mean time to detect or the mean time to discover. I think these are actually ITIL terms, but they work relatively well. And then there's the mean time to resolve. And essentially, the attacker also has their own mean time to discover, so how long is it until they actually find the vulnerability, and then their mean time to exploit. And not with all vulnerabilities, you can't necessarily exploit them at a single point in time. You can't necessarily exploit them as soon as you find something. There may be time constraints. There may be, there may be time taken just to get a large amount of people affected by the exploit, etc. So the other thing to remember, obviously, is that point in time is not necessarily the same for both us and for the attacker. Theoretically, the attacker might find it before us. They might find it after us. If it's a large announcement in a dependency that we use, then they'll find it out at exactly the same time. So our challenge is, how do we reduce the mean time to detect, and how do we reduce the mean time to resolve? Well, the mean time to detect, one of the things that you can do regardless of whether you're doing continuous delivery, is have a bug bounty program, or at the very, very least, have good responsible disclosure processes. And I can't sort of overestimate how important that is. I've reported loads of vulnerabilities myself, and it is so frustrating when you make a vulnerability report. You essentially have to tweet them publicly to say, who can I tell about this, because there's nothing on the website about how to report. Eventually you do get an email and it goes to customer services, and they sort of say, I don't know what this is, but if you mention the word security, then they get slightly worried and they contact the dev team. And then typically you'll get something back saying, oh, the dev team don't really think it's a problem. And that's because obviously it's been sort of circulated publicly and the dev team are trying to protect themselves. But it sort of doesn't encourage you to to report things when you find them. So using a sort of a whole community of white hats out there and having good sort of responsible disclosure processes is one way. Another way is obviously monitoring, and whilst you can monitor in non-continuous delivery environments, I think typically we're much better at it in continuous delivery environments. So the classic example is if somebody is attacking us, mean time to discover, and they do find something and start exploiting it, good monitoring means we can pin our finding of the vulnerability back to when their behavior is working. So essentially we're pushing it that way. But the key thing in why continuous delivery is more secure is the other, mean time to resolve. Continuous delivery is good at releasing software quickly at short notice, without a long lead time. The cycle time is by definition short. So, if we do find a vulnerability, then it should be possible for us to patch that really quickly, get it through the pipeline and release without all of the things that non-continuous delivery environments would have, either lack of CI or not having removed all the bureaucracy that's involved in trying to release software. So, the third reason, the third way of thinking about security. So realistically, security is all about having people on the ground actually thinking about security in the right way. So I want to talk about these three different ways of thinking about security. And one of them, I'm assuming that everybody in this room will already be familiar with, and it's worth mentioning for a couple of reasons. One is that, so OWASP Top 10, it is not a checklist for all of the security problems that an application might have. First released in 2010, updated in 2013, and due to be updated again this year, but it's going to happen next year, I think. It's the 10 most common by sort of collective impact is in terms of vulnerabilities. So it's not a checklist of everything that you should be doing, but it's not a bad place to start. So how many people are aware of the OWASP Top 10? And how many people feel they could explain all of the items on it relatively well? 1 or 2. Okay, so it's sort of everybody knows about it, but it's not as if it's saturated through the development and testing communities. So one thing I would recommend that you do is basically go back to your office tomorrow and find a poster and print it out and stick it on the wall. It won't sort of answer all your security problems, but it makes security visible and it starts the conversation. And to help you, we've created a poster, which is a really nice, colourful one, which will really get people talking. And if you go and follow Equal Experts on Twitter, we'll tweet out a link to that poster at some point. There's also a grayscale one in case you don't have colour printers. But get it on the wall. It provides put it near the coffee machine, and it will provide a way to start talking about security. Mentioning OWASP, obviously I should also mention the organisation sort of slightly more widely, as well as obviously the top 10. There's loads of resources on the site. They provide some good tools. I mentioned the dependency checker before, which is really good. It's really easy to integrate in, and it covers quite a few languages now as well. I think Java, C#, Python, PHP, a little bit of C++, and essentially it will automatically scan all of your dependencies against CVS reported vulnerabilities, and obviously you can continue to run that after your deployment as well to be warned of new things that are coming up. Zap proxy I won't mention too much because Ian's going to talk about it. They also have a deliberately vulnerable application that you can launch up, so essentially testing attacking against that. So third way of thinking about security. Second way of thinking about security. Now I could have used the OWASP the risk rating methodology, but I didn't want to just talk about OWASP. So this is essentially the CVSS, Common Vulnerability Scoring System. So this is a way of essentially rating vulnerabilities or potential vulnerabilities. And it's basically split into two. Exploitability, I think OWASP call that likelihood. So how likely is it that this vulnerability will be compromised, and then impact, what is the impact if it is compromised. So on this, there's a version 2 of CVSS and there's a version 3 of CVSS. A lot of people still seem to refer to version 2, even though version 3 was released last year. So I'll sort of talk about the difference between those. But the access vector is basically where logically or physically an attacker has to be in order to take advantage of a vulnerability. So the highest scoring location is basically called network. And if you remember your OSI 7-layer networking model, it's basically level 3 and above, which is people have IP access to the boundary of your system. Yep, so that's basically as remote as people can be. And to be honest, if you work in web applications, you are likely, most vulnerabilities that affect you are going to be in that highest rating level of network. They also talk about adjacent, which is essentially air-gapped, so things like getting onto a Wi-Fi network or being in range of Bluetooth. They talk about local, which means not necessarily physical access, but logical access, so having accounts on local machines, or physical access, which is where you would actually need to be able to walk up to a machine and plug something in. So in terms of the risk of something happening, the access vector is the first thing. As I say, most of you people will probably be dealing with things that are the highest risk rating for access vectors, which is the network. Access complexity, they actually changed the name of this to attack complexity, but essentially how difficult is it to attack? Are there limiting factors on when you can attack? So does it involve certain race conditions? Is it only in certain times? Is it only when a certain amount of people are online? And things like that. There's privilege that used to be called authentication, which is basically, do users need some level of authentication or privilege on the system already in order to take advantage of the attack? So this would be, it's rated just high, medium, low, but something that's high would be anybody can attack this without any account access. A medium one might be somebody who's got a user account can make an attack against another user account, and high might be that an admin account or something is required to take advantage of the attack, but they can still do things that an admin account shouldn't be able to do. There's a couple of others. So user interaction is basically, can an attacker just do this at any point in time, or do they need to make a user do something? So something where a user has to go and click on a link, or you have to rely on a user being online at a particular time would require user interaction. And there's also a fifth one, which I think is scope, which is whether or not the vulnerability can affect other systems other than the one where the vulnerability exists, but it's all a bit weird. So the impacts in terms of what will happen if this vulnerability does exist. So the first is confidentiality. So basically, can people read our shit? you've got integrity, which is can people change our shit when they're not supposed to, and availability is can people stop all of our shit altogether? Yeah. So essentially, confidentiality is things like you are insecure sessions and things like that, as well as insecure transport, or information leakage. And attacks like that. Integrity would be things like cross-site request forgeries, where people can actually, change data, or people can get privileged, escalated levels of privilege. And availability, obviously, things like DDoS attacks, or even locking out individual users can be classed as an availability attack. So using these, obviously, you can apply a score from each of these, and then you can use this nice, simple formula in order to capture an external thing, but don't bother, you don't need that. It's just a way of thinking about it, not something that you necessarily need to score yourself. So the first reason, how many people here develop in what they would call agile software development? Okay, most people. So this, it comes from a vendor, but it's quite nice. So this is the Agile Security Manifesto. And it's quite nice, it aligns very well with continuous delivery. So, first of all, rely on developers and testers more than security specialists. I am going to break the golden rule here and read this out word for word. So essentially, most software organizations that you will be in, you will sort of see people talk about security, and it generally comes down to, well, we'll penetration test it later, or we'll get the security person to come around and talk to you. And it's often ineffective, because the security people don't scale, and essentially, if you make it sound like it is somebody else's responsibility, then people will not do it. So if you make it absolutely clear that we are relying on developers and testers, it is your responsibility to make it secure, then it helps pull the accountability back in. Secure while we work, more than after we're done. You can't really avoid that if you're doing continuous delivery. You can't claim to be continuous delivery if you create some features and then suggest that you're going to secure them later on. If you're working iteratively truly, then every feature has to be complete, and definition of done includes being secure. Implement features securely more than adding on security features. The same really applies. And mitigating risks more than fixing bugs. Again, it's about looking at security as being part of your day-to-day development process rather than some sort of afterthought or some orthogonal responsibility. Okay, so this is a bit where I start ranting a little bit. So these are my pet hates. Does anybody know why this is my pet hate? Okay, so go through airport security. Yep. How many people have seen the massive transparent boxes they have, which are normally about 2/3 full of nail clippers? Yep. How many people have been into the boots in the airport and seen them selling nail clippers? Yep. That's called security theatre. Yep. Essentially, they are implementing a security control that has absolutely zero effect on security. It's designed to essentially, supposedly, increase the confidence of people that are traveling, but actually it just inconveniences them, and it in no way prevents a serious attacker. So in software, security theatre happens all the time. We see it, things like test exit reports, running penetration tests, but allowing a senior sponsor to essentially, what's the word that they use? Exemptions, that's it. Yeah, so allow a senior stakeholder to make an exemption for that security thing, so we'll actually put it into security anywhere. Any bureaucracy which is essentially trying to make it look like systems are becoming more secure, but is not raising the security level at all, or is not raising the security level enough to justify the cost, is security theatre. Bruce Schneer does some really good talks on security theatre. He talks a lot about psychology of security and things, and there's some really good stuff there that's worth watching. So I'll tweet a link out to that later. Okay, second one. So this is when people, particularly technical people, use these terms incorrectly. So just as therapy for myself, I'm going to go through these one by one, and we're going to talk about what they are and what they're not. Okay? So I'm sure you all know, but let's go through it anyway. So first of all, encoding. Yep. So for example, URL encoding or base64 encoding. Actually, I need somebody to repeat everything after me. There is no such thing as base64 encryption. Okay? Okay, so essentially encoding is used to reduce a character set so it doesn't conflict with another character set. So in a URL, make sure that things that are that would potentially conflict with a URL scheme can be passed as a query string parameter, for example. Base64, reduce it to only the first 64 characters. And there's a test here for anybody to later on work out what that actually base64 unencoded word is. I'll tell you, it says obfuscation, okay? Because essentially encoding is used for obfuscation, but it is not a cryptographic cryptographic tool at all. Hashing. Okay, so hashing, and obviously we're specifically talking about cryptographic one-way hashing. So a hash function generally takes any input and reduces it down to a fixed length. We know that. Cryptographic one-way hashing has some additional properties. So it is, if it's implemented correctly, it is infeasible to reverse the hash function. So that's one of the properties. One of the other properties is it displays what's called the avalanche effect. So essentially, a very small change in input, ends up with a large change in the output. So these are some of the properties of one-way cryptographic hashes. Everybody knows what one-way cryptographic hashes should be used for in software. Yep. Everybody here works, everybody here hashes all of their passwords. Nobody here has ever worked within a system where passwords are stored in plain text, have they? No. Okay. So I assume most people also know about salting. Yep. Hands up if you've not heard of salting. That wasn't a fair question. Nobody's going to put their hand up to that. How many people know why we salt? Okay, so it's mixed. So essentially, salting is when we store a password, we should one-way hash it. Yep. Salting is something that you would add on a per password case to the input in order to create an avalanched output. And what that means is it means that within a table, two passwords that are the same will have different hashes because they've got the salt stored against them. And what this is used for is for defense against rainbow tables. So rainbow tables basically is where somebody takes the top 1,000,000 most commonly used passwords, hashes them all using a known hash function, and then essentially when they steal your database, they can just compare the hashes that they've created against the hashes that you've got and know what the passwords are. So salting on a per row basis avoids that. Yeah, simple as that. Okay, encryption and signing. Encryption. So encryption provides confidentiality. Yep. So essentially, there's two types of encryption in terms of symmetric and asymmetric. So symmetric encryption means that we both have somehow shared a password in advance, and we use a strong encryption algorithm in order for me to encrypt it, and you can unencrypt it with the same password. So this is your, I won't say strong password actually, but this is your, add a password to a Microsoft Word document kind of thing. If you know the password, you can unencrypt it. Asymmetric is public-private key kind of cryptography. Signing, integrity and non-repudiation. So this is one of the things that people often get wrong, is that encryption does not provide integrity. So essentially, you can change an encrypted string, and it will potentially still unencrypt correctly, but the data will be wrong. Yep. So encryption does not provide integrity. It also doesn't give you any guarantee of who sent it in terms of symmetric encryption yet. Essentially, somebody could have replayed a string and things like, replayed an encrypted message, and so you don't know that it's just been sent. So you would essentially, if you are going to sign something, you would sign it with your private key, and somebody can validate it with their public key. If you are encrypting something asymmetric, you would sign it with their public key, and they can unencrypt it with their private key, with their own private key. Sorry. Right. A lot of the time, you don't even need any of these things. Yeah. The one thing that you need sometimes is just a high entropy token. Yep. So in a lot of cases, people start getting involved in cryptography when it's not really going to offer them any serious benefit. So if you are talking about something like a session key, or a web token or something, then there's lots of cryptographic techniques that you can use for those. But a lot of the time, just storing a strong high entropy session token, which is kept secret in your database, is enough. So certainly for things like OAuth and API keys and sort of one-time tokens, a GUID is strong enough. And I've had people before sort of talk about GUID collisions, as though, or UUID collisions, as though they're something that can happen. But to illustrate how sort of strong a UUID is, if you generated 1 billion UUIDs a second for the next 100 years, there's a 50% chance that you'd get a single collision. So if anybody ever tells me that they've had a UUID collision, first of all, I'd tell them to go and check the code. And after that, I would tell them to go and buy a lottery ticket, because it's just not going to happen. OK, so my final pet hate, and it's not actually these symbols specifically, but it is related to these symbols that you get on website. It is insufficient transport layer security, or it is lack of encryption on the network layer, or it is people not using HTTPS. Yep. So it's unbelievable if you look for this, how often you find yourself not on HTTPS. You know, massive amounts of the internet in all cases are still, you know, not having HTTPS. You still get login forms of big organizations that are not HTTPS. You know, some of those where, you know, even you still get posts where it's not HTTPS, you know. You get lots where the login might be over HTTPS, but the rest of the session isn't. So, you know, HTTPS really, if you're going to do it, it needs to be good HTTPS, yep, obviously. It needs to be end-to-end, so it needs to be you know, not necessarily just to your boundary, but think about the HTTPS internally as well. The old sort of soft outer, hard outer shell, soft inner, just doesn't really exist these days. So HTTPS end-to-end, and it needs to be for the whole session. So, you know, you've seen situations where you might log in over HTTPS, so the password is protected, but then the cookies are sent over HTTP for the rest of the session. So to be honest, you're wasting your time, because if they can get the session, then the password probably has a little value. If they can get the session, they can probably get enough information to launch a phishing attack against you or something and get your password another way anyway. So protecting only part of the session has really no value. Obviously, what HTTPS protects against is the man-in-the-middle attack. So, you know, that could be caused by untrustworthy Wi-Fi, compromised routers, which is a massive problem because hardware manufacturers don't seem to be able to write secure software at all. Poison DNS. There's loads of reasons. I think this year or early next year, Google are going to actually start giving higher ranking signals for things that are over HTTPS. So even if you've just got a pure content site, there's going to be beneficial to use HTTPS. And these days, to be honest, there's no reason why you shouldn't. Let's Encrypt has come out of beta in the last couple of months. It means that you can automate a creation of HTTPS certificates for free. You know, there's limitations to numbers, but there's no real reason why you can't have HTTPS in this day and age. The other thing that's worth mentioning when we're talking about HTTPS is HSTS, which is HTTP Strict Transport Security, which is basically a set of headers that you can set, which means that the browser will refuse to request an HTTP version of your site. So essentially it prevents downplay attacks where people bounce, where an attacker bounces your users from HTTPS back to HTTP. You can also submit your site as part of the HSTS scheme. You can also submit your site to a list which gets loaded into the browsers. So even if it's a brand new browser and it's a first request and they go to HTTP, actually the request will be HTTPS. Okay. So this is eBay sign-in form. Yep. And you'll see on the left, I've got, this is essentially after submitting the form. So on the left, I've got an email that does not exist. And on the right, I've got an email that does exist on eBay. Yep. And when I submit them, I get exactly the same error message back both times. Yep. It says, oops, that's not a match. Yep. Why does it do that? Why doesn't it tell me whether the email exists to make it easier for me to know what's wrong? Enumeration of usernames. I wrote a whole blog post about this. If you search for my Twitter thing and enumeration, it was a couple of years ago, but it covers it in a lot of detail. So is this a good thing? Yeah? Everybody does this, yeah? Brilliant. Of course it's a good thing. You know, if you enumerate usernames, then it means that people can target phishing attacks. You know, they can guess passwords more easily. You know, they can know that they've got a correct username in order to guess passwords. They can target your, you know, competitors can target your clients, etc., etc., etc. So considering that's a good thing, why, when I go and reset my password, does eBay tell me that the email address doesn't exist on the system? And why, when I go and register, does eBay tell me that it does exist on the system? The reason is because they have some security theatre on the login page to prevent enumeration of usernames, but they don't defend against it elsewhere. 95% of sites on the internet have this problem. Yep. And it's kind of pointless. You know, either make it easy for your users on the login page and accept that you allow enumeration of usernames, or fix it here. So what I've done with one of my clients in the past is that for both of these scenarios, either new registration or resetting of passwords, you enter your email address and you get sent an email. Makes no difference who you are, whether you exist or anything else. If you don't exist, then that has a link which takes you to a, would you like to create an account, or would you like to try another email? Yep. If you do exist, it takes you to something that allows you to reset your password. Yep. It's trivial to do. In a lot of ways, it actually improves the user experience because you don't have to do all this kind of links around, forgot my password or, you know, anything else. You just say, looks like you're having trouble logging in, give us your email and we'll sort you out. I'm running slightly short of time, so I'm going to actually, we'll do these and then I'll skip through another bit. So unvalidated redirects. So unvalidated redirects are essentially a way of hijacking somebody's journey, rather than somebody's session. This also applies to forwards. So it could be a forward server side where the vulnerability exists, but we'll talk about the redirects because it's one of my favorites. So a classic example of this is a login form that has a send to parameter or a success parameter. So you go to a login page, it has a success parameter, and after you log in, it redirects. And that might look something like this. Yeah. Example.com login, on success, go to /account. Yeah, perfect. Nothing wrong with that. Unless I send somebody an email that does this. Yeah. So if this /account is not validated correctly, yeah, if it's not sanitized, then after you log in successfully, you'll get redirected to my website. Yeah. And what I would typically do in this account, not me obviously, but if I was demonstrating this, what I would typically do in this case is I would make this a phishing page that looks very much like your login page. And I would give you a incorrect username or password error message. And when you resubmit your username and password to me, I would then redirect you back to example.com, and you would be none the wiser. You would think you mistyped your password, but I would have your password, and you would carry on your way. You can do this. Another way of doing this actually is that if this URL, rather than being evil.co, is something like this. So this is kind of a domain hijacking sort of thing. I don't know how many people can see it, but this domain here is actually comllogin.on. Yeah, and essentially, it's very, very hard to see that isn't the actual genuine, the genuine case, especially if people aren't using HTTPS. So it's another reason why you should use HTTPS. Query string parameter is not the only place that this can exist. So I've seen places where a cookie value is used to manage something like which subdomain you should go to, and if you were to enter a full URL with a query string or with a question mark at the end, then it would mean that it would actually redirect you to someone else's site. And that's particularly dangerous because if I set a cookie value through an XSS attack or something, then at any point in time, as long as you don't clear your session, you go and visit something, whether you followed a bookmark, followed a link from a trusted source, typed it directly into the browser, and you still end up on some sort of malicious site. So that's pretty dangerous. And it can also be persisted. Because of time, I'm actually going to skip this, but ask me about fly phishing later on. There's a type of persisted attack for unvalidated redirects. Okay, cross-site request forgery. So most people have heard of this. Yeah. Okay, so I don't know, can people see this on the screens? Is there a screen there? So I'm just going to show this line by line because this is a typical cross-site request forgery attack. So HTML body. So we've got an image here, which is some hilarious cat playing a piano picture or something. Yeah. And that's just the distraction. That's so that people look at it, think that they've been there for a good reason, and close the tab. What we've then got is a form, which you'll see is hidden, so display none. And this form posts to our target that we're trying to attack, so essentially to the vulnerable system. Yeah? And it targets a hidden form, which is actually an iframe. Yeah? This submits an input, which is an email address, and it has one of my email addresses as the value. Yeah? And as I say, the iframe there, which is just to receive the post so that the user is none the wiser, and then a bit of script that just says submit the form. Yep. So when you load this page, you see a picture of a cat playing a piano, and in the background, a response gets sent to the target system. Yep. And with any cookies that you might have, because that's what happens, the response is hidden in the iframe, but essentially, I've set your email address to be an email address that I control. So actually what I would normally do in here is I would probably have two more cross-site request forgeries in there. I'd have one that does a reset password for this email address, and I would probably also log you out just for good measure to make it harder for you to fix it or notice that there's been a problem. So essentially at that point, I have got your email address, so I've got your account in this particular case, yeah? The way that you defend against this, typically cross-site request forgery tokens, so essentially a separate token on each page which is not in the cookie, so essentially managing state server side. If you're talking about AJAX requests, you can defend against them by using header synchronization. So essentially the AJAX takes a cookie value and adds it to a header on the request as well as sending the cookie back, because obviously in the cross-site request forgery case, the attacker never sees the cookie value, they just send it blindly. The other way to do it, actually, which is often simpler, is if you're doing any sort of action which can be changed and you care about the integrity of that change, is also to ask for the password. when it's changed. So asking for a password when a password is changed is a classic. It defends against CSRF as well as manual session hijacking, where somebody just walks up to a terminal. I've got to do this one, so bonus, self-XSS. So everybody knows what cross-site scripting is. Cross-site scripting, injection of JavaScript. Yep. This is something that's been happening recently. So self-XSS. So you get some sort of viral thing like this, and basically it says you can hack any Facebook account by going to their profile. It says click on Inspect Element and click the console tab. So basically open developer tools, and then paste in this payload. Yep. And then it says good luck, which I think is really nice because you're going to need it. Yeah. So basically what this is getting is people that don't understand anything about the browser to paste a malicious payload directly into the console, which will execute. Yeah. Which is brilliant. I mean, it's I think it is a great attack. But the interesting thing about this is that, Facebook could have said, you can't protect idiots. You can't protect people that don't know what they're doing. But they didn't. So what they did was that on every page on their site, they output to the console now a warning message. Yeah? So if you go to Facebook and inspect element and look at the console now, you'll see that on every single page, they basically broadcast to the console something warning you about this very attack, which I think is brilliant because essentially, rather than just thinking, well, it's not our fault, it's not in our domain, they've thought about the users and thought about how they can potentially help them. So this is what we are going to do today or have done today. And essentially, I think we've got to just sort of summarize or start off, depending which way you want to look at it, to say that security is hard. Yeah? Has everyone seen that before? It's brilliant. I absolutely love it. This is sort of the way that security works in a lot of organizations, is that, it's great, you've got a padlock, you've got a lock, you've got a chain. What could possibly go wrong? So I said I'd sort of introduce myself. So I think the way that I want to introduce myself is along the lines of this DevSecOps. So most people have already heard of DevOps, and obviously, DevSecOps is the next thing. Now, I'm not using this to say that I'm DevSecOps. I'm using it to try and say what I am. So my name's Phil Parker. I'm a partner with Equal Experts, and Dev, I've probably not coded for more than 20 days a year for the past 10 years. So I'm definitely falling into post-technical. When I do code, my team looks very concerned, so that's kind of where my dev credentials lie. Sec, I have no qualifications in security. I have no certifications. I've never been on a training course of anything for security. Ops, I still get ln-s arguments wrong every single time, but then I think everybody does on that. So, welcome to my talk. And in terms of answering, how do we achieve continuous security? I think we know it's to build security in.